Assalamualaikum warahmatullahi wabarakatuh and good day. My name is Muhammad Amiruddin bin Mohktar. For my FYP project title is Re-evaluation on the slotted tension shear test method of the composite laminate, and my supervisor for this project is Prof. Madya Ahmad Kamil Hussein. In this presentation, I will explain the introduction of my project, problem statement, objective, literature review, methodology, and a primary result from the previous study. For the introduction, this study is about improvement of slotted tension shear test method. Slotted tension shear method can be an alternative shear stress method. This type of test is simple and cost efficient from any other test method. By using MEC software, we want to see the best profile slotted used for the specimen before testing is conducted. With the result, we want to compare the best profile to achieve the best range of shear stress. Here are examples of the slotted tension shear that performed on the lab. For the problem statement for this project, what inspired me to do this kind of project? A shear test is designed to apply force and stress to a test sample to experience failure along a plane. Shear stress commonly used to determine the shear strength. We want to see maximum shear stress that material can endure before failure happens. But right now, there are too many types of shear tests that can be used to testing the material. The torsion test method is the most common used type of test that has been using to test material. But for composite laminate material, to use torsion test is expensive and need high precision tool to produce the specimen. Second, problem they are result of a pure shear stress produced may be vary. It depends on the profile slotted use. For the objective, what I need to be achieved in this project? First, to investigate the reliability of the slotted tension shear method. This to measure shear properties of carbon epoxy using NC finite element software. As we know, with the technology right now, we can simulate the testing without do it on the lab. This can help researchers to cut the cost and more time efficient. NC software are among the best finite element analysis, or we call it FEA, to analyze the property of material. For the second objective is to evaluate the best end profile of the slot for the test sample. In this project, I will use three types of profile to be simulated using NC software. First is round shape, V shape, and third is square shape. This is because different type of slotted will produce different type of normalized stress contours. Third objective are to assess the effect various laminate orientation on shear properties measured by the slotted tension shear method. As we know, the composite laminate material consists of laminate of combined material. It can be combined by different orientation. The type of different orientation will affect the performance of the composite material. This picture shows orientation of a laminate. Then we go to the next part, which is a literature review. In this section, there are several things that need to be highlighted, including composite material, slotted tension shear stress by axial method, modified slotted shear test, specimen for the slotted shear test, carbon epoxy specimen, and finite element analysis. What is composite? Composite material consists of two or more components that has different properties. This type of material are different from the traditional material. These combinations are usually made of fiber and metric material, even though they were different completely in terms of properties, but the combination will be complementary for these two. The slotted tension shear test by axial method is based upon the well-known principle that one-on-one implant by axial normal stress is equivalent to a pure shear stress on the plane oriented 45 degrees relative to the orthogonal axis of applied load. This stress that can be closely attained with a conventional size. For the simulation for my project, I will use modified slotted shear test method that has been done by Nunes on the research paper. Title is Modified Slotted Shear Test for a thin sheet of solid polymer under a large deformations. The material that I will use for this project are carbon epoxy that has a Young modulus value range from 3.3 to 6.4 GPa. This value I get from the journal Shear title Epoxy Composite using functionalized alumina pellet as a reinforcement. The reason for this material was chosen because this type of material can easily to obtain in the lab. For the size specimen, the picture show basic model. I will draw in axis for 3D model. For the methodology, first I be drawing 3D model of the specimen that want to be tested using ANSYS software. After the drawing of 3D model, the model will be meshed. Then put the boundary condition for the 3D object. Run the simulation and analyze the result. The step will be repeated by using different slotted end that is V-shape and rectangular shape. The 3D model need to be redesigned back to change the surface of the slotted end profile. The expected result for this project should be same as the previous study for the round-shaped slotted end profile. The stress test in the specimen is highly complex. Previous finite element study has been conducted. From the study show high stress concentration at the round notch tip of the specimen. In this region, axial stress are very high than other places. Also, shear stress and the transverse at this location is high. This figure shows the stress distribution in the 0-degree specimen. This configuration uses the spacing between notches where 0.6 times the depth of the sample. The nominal, or we call average shear stress, is 1.7 shear. Shear being applied to the tensile stress. The shear stress is 0.6 over a large portion. The shear part for the 0° specimen at the notch tip stress concentration factor is 1.57. At the center of specimen area, a thin region of uniform shear stress is equal to 0.6 at this, indicating we can measure the shear strength by using this method. Okay, that's all for my presentation, and thank you for watching this.